Hey everyone, welcome back. Today we are going to do a quick little review of what we've talked about so far in Chapter 11 with data displays and data analysis. We're actually halfway through the chapter. It's a really short one. So today's questions are just going to be review questions over the three topics that we've covered so far in this chapter. So with that in mind, I made a few review questions that are going to look similar to the ones in the little review quiz today. Typically, these review quizzes are a little more challenging than the questions we have, and so I'm hoping that people can get a good score, but typically our scores are a little bit lower on these than on the normal day-to-day assignments. So here we go. The first question is going to look very similar to the one on the online questions today. It says, find the measures of center, mean, median, and mode. It's going to give you a list of numbers. It's going to say, find the mean, find the median, find the mode. And then it's going to say, pick the best representative or representatives. So I didn't put any numbers actually on the list or out here for us to actually calculate because I figured we already know how to do it. Quick review, mean, you add up all the numbers, hit equal, divide by how many numbers there are. That's going to be easy. Median, put the numbers in order from least to greatest or greatest to least, but I've never met a student who goes greatest to least. Everyone always goes least to greatest. Find the number in the middle. If there are two numbers in the middle, you add them up and divide by 2, or you just find the average or the mean of those two numbers. The mode is just the number that shows up the most often. And then how do you choose the best representative? This is the part that I think is a little bit harder. Usually you're going to have to decide between the mean or the median, or sometimes you can pick both, right? If the data is very symmetrical, if it looks like you have about the same amount above the mean that you have below the mean, if it's very symmetrical, I would pick the mean. If it's skewed a little bit, you can pick the median. If the mean and the median are both really close, you could probably pick both. In fact, today on the online questions, number 1, it's going to want you to pick 2 of them. So you're going to pick 2 out of the 3. Mode is probably not the one I'm going to pick unless the mode is like the exact same as the mean or the exact same as the median. But if the mode is like a number that's really smaller than the mean or really bigger than the mean or the median, I'm probably not going to pick mode. So most times I'm just going to pick mean and median if I have to pick 2 out of the 3. So number 1 is going to be pretty easy. Number 2, it's going to say find the change in our data, in our measures of center, find the change in the measures of center if the outlier is removed. So number 2 is going to require you to do the mean, median, and mode 2 times, right? For example, here's my list of numbers, 1, 3, 5, 5, 2, 7, 26. Obviously, there's one number that's bigger than all the others. It's right here, right? 26. And now my blue marker is not going to work. Okay, that's fine. So what you're basically going to do is, first time, you're going to do the mean, median, and mode, just regular, right? So if I had to do the mean, the median, and the mode, I'm just going to do it like normal. The mean is going to be where I add them all up and divide by how many numbers I have. If I add these up, let's see, that's 4, 14, 15, 16, 23. 23 plus 26 is 49, assuming I didn't make a mistake there. That's 49 divided by 1, 2, 3, 4, 5, 6, 7. 49 divided by 7. Oh, wow, it works perfectly. I didn't even mean to do that. So my mean is 7. Then I would do the median, put them in order from least to greatest. That would go 1, 2, 3, 5, 5, 7, 26, and then find the number in the middle. So the number in the middle would be, or I might have 2 numbers in the middle. Nope, I have 1 in the middle. So I have 3 on the right and 3 on the left. My median is 5. My mode, the number that shows up most often, is also 5. So those are my typical answers for mean, median, and mode. But now it's going to ask you, find how your answers change if the outlier is removed. So now what I'm going to do is I'm going to take this number 26 that was our outlier because it was way bigger than all the others, and I'm just going to delete it. It's not even in the list anymore, right? So now I only have 6 numbers, and now I'm going to do mean, median, and mode a second time. So let me do mean, median, and mode one more time and see if they change. And so the mean is not going to be 7 anymore. The mean, I'm going to add them all up. Let's see, 1 plus 3, that's 4. 14, 15, 16. 16 plus 7 is 23. 23 divided by 1, 2, 3, 4, 5, 6. Oh boy, that's not going to work evenly. That's going to be 3 and 5/6, isn't it? That's like 3.83 with the repeating bar, I think. 23 divided by 6. Yeah, there it is. So my mean is 3.83 with repeating bar. I think it actually says round to the nearest tenth in our online questions today, so I'm just going to put 3.8. The median, the number in the middle, is possibly going to be different as well. Let's see, 1, 2, 3, 5, 5, 7. If I go to the middle, I have two numbers in the middle, 3 and 5. 3 and 5, what's halfway in between those is 4, or I could do 3 plus 5 and then divide by 2. The mode is still the same, though. The mode is still still 5, isn't it? Because the number 5 shows up twice. So basically, you're going to have to do mean, median, and mode 2 times. You'll do it once with all the numbers. Then you're going to take away that outlier, whether it's a number that's really big or it could be a number that's really small. You're going to knock that out of the list. You're going to do the mean, median, mode again. And now your final answer, what you type in the actual boxes, is going to be how much your answers have changed. What has happened to our mean when we took away the outlier? Okay, so it started out at 7, and now it went down to 3.8. So I'm just going to say, okay, it was at 7, and it went down to 3.8. It has decreased by, and you can work this out, 3.2. It's gone down by 3.2. It's very important that you put this negative sign on here. Negative 3.2. If you just put 3.2, they think it's indicating that it went up, but it didn't go up, it went down. So I'm going to put negative 3.2 to show that it went down. The median was at 5, and then when I took away the outlier, it went down to 4, so it went down 1, negative 1. The mode was 5, and it stayed 5. The mode stayed the same, so I'm just going to put a 0 over there. The mode has not changed at all. Or there might be an option, if this is like a little drop-down box, there might be an option that says did not change or unchanged. But if there's no option, you have to type it, just put in a 0 if you have to put a number. Okay, so that is number 2 on today's questions. Hopefully we're doing okay on those. Those I hope aren't too bad. Number 3 is a question that I really did not address whenever we went over this in the second lesson in this chapter, and I apologize. There was so much to cram in there, I just kind of took this out because I didn't feel like it was the most important, but I can throw it in here today. It's really not that bad. It's going to give you a list of numbers. They're going to say, hey guys, they're not actually going to tell you what the numbers are, right? There's no actual list of numbers like I had on the last one, where I wrote 1, 2, 2, 3, 5, 5, 7, 26. They're not actually going to give you the list of numbers. They're just going to say, hey, here are the measures from a group of data. So this magical data that you can't actually see, this magical list of numbers has a mean of 21, a median of 23, a mode of 19, a range of 7, and a standard deviation of 2. And it's going to ask you, what would happen to the mean, median, mode, range, and standard deviation if every number in the data set is increased by 7, right? So if you just take your imaginary list of numbers, kind of similar to the one we had on the last question, they're saying, okay, what happened if you took every number in the list and just increased it by 7, and you added 7 to everything, right? All your numbers would go up by 7. What's going to happen to all of your answers if we just take all the numbers in our list and magically add 7 to them, just for fun, right? Now, I didn't talk about this in our other video, but here's basically what happens. The measures of center, the mean, the median, and the mode, the measures of center will all go up the same way that all the numbers in the list did. So if the numbers go up by 7, all of these are going to go up by 7. So the mean is going to go up from 21. It's going to be 21 plus 7. The median will go up by 7. The mode will go up by 7. So all the measures of center, right? The measures of center are all going to do the same thing that happened to the numbers. So if the numbers go up by 7, they're going to go up by 7. If the numbers were going down by 5, they would go down by 5. If the numbers were going up by 3, these would all go up by 3. The range is not going to change, because if you think about it, like here's my original numbers. Look at these, 26 minus 1. Isn't that range 25? And then look at this. Isn't this range also 25? 33 minus 8? So the range is not going to let me try that over again. The range is not going to move. It's going to stay the same. And the standard deviation is going to stay the same. Since every single number was affected the same way, the two measures of variability, right? These are the measures of variability. They will not change at all. So on your question today, it's very similar to this, on the computer, it's going to look almost exactly like this. Instead of going up by 7, it's going to be, I don't know, doing something, going up by 8 or going up by 10 or going up by 3 or going down by 5 or something. So the mean, median, and mode, whatever happens to every single number, just do that to the mean, median, and mode. Do not change the range and the standard deviation. Okay? Keep those the same, and that's all you need. Number 3 will be an easy one. Number 4, we're going to talk about box and whiskers. How can you interpret a box and whisker plot? Very simple. This one should be an easy one too. So they're going to give you a box and whisker, like I just made an example one up here at the top. They're going to have some positives and negatives on their number line. That's okay. It's going to ask you, okay, what's the range? Can I tell the range from a box and whisker plot? Of course you can, right? You know the biggest number is over here, the upper extreme. You know the smallest number, way down here, is -3, and you just ask yourself, how far apart are those numbers? Or the biggest number minus the smallest number, 7 minus -3. Okay, minus negative is the same thing as plus, so my range is really 7 plus 3, which is 10. The range is 10. That's going to be the first part of number 4. The second part is going to ask you to actually interpret the graph as well. 75% of the data is in between -3 and what number? You're going to have to pick a number right here. Okay? Remember how box and whiskers work. Each segment of the box and whisker represents 25% of the data. So like right here, from here to here, that's 25%. Since they said start at -3, I'm going to start at -3 and go until I get to 75%. So this first little segment is 25%. The first part of the box is 25%. So there's 25, right? So I'm at 25 and 25 right now. I'm at 50. And then here's another 25% from the next dot to the next. So there's my 75%, right? I've gone 25, 25, 25. So from -3 to here, +3, 75% of my numbers are in that range. Okay? The top 25% would be this whisker up here, but it didn't ask me about that. It just said the first 75%. So there's 25 right there, 25 right there, 25 right there. Okay, then it's going to ask you for the interquartile range. The interquartile range is different than the range we did up here. Interquartile range is just the range of the quartiles, the right side of the box minus the left side of the box, quartile 1 with quartile 3. So IQR, or interquartile range, you just take this number, 3, and you subtract it with this number, -2. So I'm going to do 3, the big one, minus -2. And just like up here, minus and the negative is really the same thing as plus. 3 plus 2 is 5. So the interquartile range, in case you forgot what that was, is 5. It's the right side of the box minus the left side of the box. Okay. The last part of this question is going to ask you, are the data are more spread out where, right? They're going to ask you to look at the whiskers. Do you see how this whisker is really long and this whisker is really short? What that means is these numbers are closer together. So there's a lot more numbers in here than there are way out here. See how this whisker is much longer? This would be one that we would call skewed right? This is skewed to the right. When something is skewed to the right, it means most of the numbers are over here. Most of the numbers are on the left, but it's called skewed right because you've got this long whisker over here. So I would say more of the data are more spread out over here where it's really, really long. The whisker being long over here is going to say that the data are more spread out above quartile 3, right? This is the third quartile. Above Q3 than over here, which is below quartile 1. Below quartile 1. So how do you answer that question by looking for which whisker is longer? Okay. That is the only box and whisker question for now. The next one, number 5, is going to ask you to make your own kind of frequency chart here so you can figure out if data is symmetrical, if it's skewed left, or if it's skewed right. And I don't think we had to do that yesterday when we talked about histograms and the shape of distributions. So it's going to say organize data using 5 intervals beginning with, and it got magically smudged there, beginning with 0 to 2. So they're going to say start with 0 to 2, and they want 5 intervals. Okay, now be careful. 0 to 2 includes how many numbers? It includes 0, 1, and 2. It includes 3 numbers. So your next interval should also include 3 numbers. So instead of 0, 1, and 2, my next group should be 3, 4, and 5, right? It should be the next 3 numbers. 3, 4, and 5. Then the next group would be 6, 7, and 8. Over here, my next group would be 9, 10, and 11. My final group would be 12, 13, and 14, and that is 5 intervals. So I really don't need this down here. That's just an extra row in the table. I guess I don't even need it. So you're probably going to have to get some scrap paper and do this on your own. And now you just count. I just made up some numbers over here. And then you just do little tally marks, right? The number 10 would be right here between... Actually, switch colors. That's not going to show up very well. The number 10 is going to be in between 9 and 11, so I make a mark right there. The number 8 would be from here, 6 to 8. The number 7, right? I mean, you see how this is working. You just make a little tally. 2 would be in this category. 1 would be in this category. And then you're going to have to just kind of fill out your chart like this. Just knock off each number, put a little tally mark in the right interval where it belongs, 14. Whoa, over here in the big one. 2, 3. And so anyway, this is a little bit time consuming. It's not necessarily hard by any means, but it does take a little bit of time, especially whenever you wrote as many, or if they give you as many numbers as I did. I don't really know why I gave myself so many, but that's okay. I'll make it work. 12, we've got a 1, we got a 3, we got a 7, and we've got a 9. Okay, so you're going to get all your numbers in there. Now, typically I would add all these up and make sure it's the same amount of numbers that I have in my list, but for the sake of time, we're not going to do that today. We're going to act like I got it all in there. And now it's going to ask you, is this data symmetrical? Is this data skewed to the left, or is it skewed to the right? And so if you just kind of free-handed here a little histogram, which I'm not actually going to draw it, but if I did my little histogram here, think about how high my bars would be, right? This first bar would be 5. 1, 2, 3, 4, 5. I'm just going to go up to 6. If I did actually have to do a little histogram, my first bar, this is 5, would have been up to 5. 1, 2, 3, 4, 5. Right? So my first bar would look like this. And then my second bar was also 5. It would look like this. The next bar was 6. It would actually be a little bit bigger. The next bar is 3. And then the next one is only 2. Right? And so it's going to ask you, is this symmetrical? Is this skewed left, or is this skewed right? Now, mine is not exactly the best example, but I think, I would not call it symmetrical, because see how tall these are on the left, and the 2 on the right are definitely the shortest? I think this one has more of its data over here. See how the tall bars are more on the left? When more of the data is on the left, I think you would call this skewed right. When the data is on the left, it's called skewed right. So that would be how I would make my decision. I think the one in the on the questions today is going to be a little bit easier to see, but that's what you'll have to do, excuse me, as far as making your own intervals and then doing the tallies. Okay, I'm almost done, I promise. These last two, I just wanted to give you a quick review of the stuff that we did yesterday, because I had some people do it perfectly and get it right on the questions. I had some people get confused, and I could tell it messed them up on quite a few points yesterday. So I want to do a quick review because I don't think I did a good enough job emphasizing it yesterday. Okay, whenever you have data in a histogram, or if it's a stem and leaf, it doesn't really matter. Here's how you can tell what they are. Symmetric, right? When something is symmetric, it looks very symmetrical, right? Like the left side looks like the right-hand side. When something is symmetric and it asks you which measure of center is the best, you're going to use the mean. When it asks you which measure of variability is the best for this data, you're going to use standard deviation. You're always going to pick those two when the data is symmetrical, right? When it's symmetrical. Okay, now here's the key difference, and this is what some people got confused on yesterday. How do you, well, let me just start over. This is called skewed to the right. When most of the data is on the left, you call it skewed right. And we had a couple people yesterday who were saying when it's skewed right, most of the data is on the right. And when it's skewed left, most of the data is on the left. No. And that's not actually right. I know it makes sense to think that way, but that's not actually how it works, right? When most of the data is on the left, we call it skewed right. So it's the opposite, right? So like over here, you can see the tallest bar. Here's my tallest bar. and here's my second tallest bar. Those are on the left half of my graph. So most of the data is on the left. My tallest bars are on the left. When the tallest bars are on the left, you call it skewed right. And that's a big difference. We had some people mess that up yesterday. The same thing over here. Like on this one, my tallest bar is over here. It's this one. And my second tallest bar is right here. And so my two tallest bars are on the right half. And so when most of the data is on the right, we call it skewed left, right? Skewed left. Because if I drew this little bell curve, look how long the left-hand side would be, that little bell. Or over here, if I draw this curve, look how long that slope is on the right. That's where the skewed right and the skewed left comes from. It's from that long slope that you get whenever you make the little curve. And so when most of the data is on the left, you call it skewed right. And when most of the data is on the right, you call it skewed left. We had a couple of people who got those backwards. Either way, on both of these, when the data is skewed, you're not going to use mean to describe it anymore. Now we're going to pick median. Doesn't matter if it's skewed left or right. Anytime it's skewed, you always pick the median as the measure of center. And you always pick the 5-number summary. Remember, that's like the upper quartile, lower quartile, upper extreme, lower extreme, and the median. You always use the measure of center, the 5-number summary as the measure of variability. Okay? So, symmetric, pick the mean and standard deviation. When it's skewed right or left, pick the median and the 5-number summary. Okay? Skewed right means most of the data is on the left. Skewed left means most of the data is on the right. That's a big difference. A lot of people get that confused, and it's really easy to mess up. Okay, the last thing I want to say, 2 last things, and then I'm done. You can also do symmetric skewed left and skewed right with box and whiskers. I didn't really hit it too hard on the day we did box and whiskers, but you can, right? How do you know when it's symmetric? A symmetric box and whisker is going to have the whiskers about the same length. Right here, the whiskers are about the same length. My median is kind of right in the middle of the box. That's symmetric, right? So remember, symmetric, we're going to use the mean to describe it. We're going to use standard deviation to describe the variability. You see how this one is different? And this one down here? Skewed right. Skewed right is easy to see because look how long this whisker is, right? The whisker is really long on the right. Just like here, see how the slope is really long on the right, right? Most of the data is on the left. And see how close these are together over here? See how close that whisker is? And see how close, well, it doesn't always have to look like this in the box, but it's definitely always going to be this with the whisker. When this whisker is short, that means there are a lot of numbers in here. The data is really bunched on the left. And over here, it's really spread out. So when most of the data is on the left, we call it skewed right, because look how long that whisker is. Same thing over here on this one. This is the opposite, right? This whisker is really long compared to this one. And so this one has a really long left-hand side, which we would call skewed left. Skewed left means most of the numbers are generally more congregated on the right. They're closer together on the right-hand side. So that's what it'll look like if it's a box and whisker plot. And then the last thing I want to say, if it is symmetrical, let me actually erase these. Oh, that's smeared. That didn't erase very well. Apologize. If it is symmetrical, if it is like this, right, and you're using the mean and the standard deviation to describe it, 68% of the data are within 1 standard deviation of the mean. So for example, if I said, hey, this data is symmetrical, and I told you the mean was, let's just say the mean was 10, and then if I told you the standard deviation was 2, I would know that 68% of my numbers are within 1 standard deviation away from the number 10. That would mean 68% of my numbers are in between 2 places above 10 or 2 places below 10, right? And so if you just took the number 10, think about it, what would be 2 places bigger than 10? 2 places bigger than 10 would be 12, and 2 places below 10 would be 8. And so I would say 68% of my data is in between 8 and 12. 68% of my data are in between 8 and 12. 2 above 10 and 2 below 10. And then if you extend that one more standard deviation away, if we do 2 standard deviations and we go 2 more to the right and 2 more to the left, you're going to get, like if you go 2 more places to the right and if you go 2 more places to the left, excuse me, you're going to get 95% of the numbers, right? So if we go 2 more to the right, 10 plus 2 plus 2, we're all the way out here at 14, or 10 minus 2 minus 2, we're going to be all the way down at 6. And so I could say 95% of my numbers are in between 6 and 14, right? And so there's 1 standard deviation away includes 68% of your data. And if you include that to 2 standard deviations, now you get 95% of your data. Okay, that's it for today. I'm going to put the questions on the Big Ideas Math site. I think there's like 8 or 9. They should mirror the stuff that we've talked about in here. Hopefully you can do your best, and hopefully our grade will be okay, but if it's not a big deal. Feel free to email me if you have any questions while you're doing it, though. Thank you so much, and I'll catch you guys tomorrow.